All right, Math 2, we've got lesson 1.3.3, more angles formed by transversals. All right, so this says determine if the angles are congruent or if they're supplementary. Basically, anytime you have two parallel lines and a transversal, you're going to have either angles that are congruent or angles that are supplementary. So based on what we've seen last time, we were looking at corresponding angles. And what I can see from this first one is that angle A right here, this angle is corresponding angles with this one down here. Okay, so angle A and this angle that's not B down here, those are corresponding angles. So this means this angle is also whatever A is. So what we have now is these two angles. Those two angles together make up a straight line. So those would be linear pairs, and linear pairs are supplementary. So we're going to say linear pairs. I can't spell. Linear pairs are supplementary. All right, next one. We've got this angle way over here, and we've got this angle way over here. Let's start with corresponding angles again. We'll start with A this time again. So there's A. The corresponding angle that goes with A is down here. Corresponding angles are congruent. So if this one's A, this one is also A. And so now we've got these two angles. And if I'm just looking at this bottom part of the paper here, that's two lines that cross each other. And it looks like I got vertical angles. So this angle is also going to be the same size as angle A. So now we've got corresponding and vertical angles, and all that stuff is congruent angles. So these two angles are congruent. All right, last one on this group. We've got angle A and angle B. We'll start with A again, and just like last time, we'll look at corresponding angles first. So that's A, and this angle would be corresponding with it. So this one would also be A. And now, similar to number one, we've got two angles that make a line, and linear pairs are supplementary. So those two angles have to be supplementary. They add up to 180. Next, alternate interior angles. Okay, alternate interior angles, the name says everything about it. Alternate. Alternate means that they're on different sides of the transversal. So this would be the transversal, and they'd be on different sides of that transversal. So our transversal is this line AH. Alternate means different sides of the transversal. Interior. Interior means that both of the angles are between the two parallel lines. So this section here, that section that I'm coloring in yellow, we would call that the interior, as opposed to the exterior. In purple, this is the exterior. These two are exterior. They're outside these two parallel lines. So the two angles that we're talking about have to both be on the interior of the two parallel lines. So both of these, both angles are on the interior. The last thing that we need for alternate interior angles is we need them to touch a different parallel line. So one of the angles will touch like the top parallel line, and the other angle will touch the bottom parallel line. So they're going to touch different parallel lines. All right, so looking at this, we've already got some alternate interior angles marked. This angle right here, this is the angle BCF. So BCF right here, and this angle here, GFC maybe, so GFC, those are what we would call alternate interior angles. And what we need to remember about alternate interior angles is alternate interior angles are congruent. They have the same measurement of their angles. So these two angles, angle BCF, that's this top angle up here, and this angle down here, we'll call that GFC. Now we also have one other pair of alternate interior angles. I'll do it in green so it's not confusing. So this angle here and this angle here would also be alternate interior angles. Alternate means different sides of transversals. These are on different sides. They're both interior. They're both in the yellow area. And then this one touches this top parallel line, and this one touches the bottom parallel line. So those ones would also be alternate interior angles. So that would be angle DCF. And this angle down here, we'll call that EFC. So those would be alternate interior angles. And alternate interior angles are always going to be congruent. Kind of like corresponding angles are congruent, alternate interior angles will also be congruent. Now, as a side note, there is such a thing as alternate exterior angles. So like this angle up here, and then this angle down here, those would be called alternate exterior angles, and they would also be congruent. For some reason, this book doesn't add alternate exterior angles, but it's a thing. Same side interior angles. Okay, the word same side, that means they're on the same side of the transversal. So the previous one, they were different sides. This is the same side of the transversal. The word interior means just like the last one, they're going to be on the inside, this yellow area there. So both angles are interior. Both angles are on the interior. And then, just like the last one, they have to touch different parallel lines. So here we've got already marked. I'll highlight it in red here. So these two angles, we would call them same side interior angles. They're on the same side of transversal. They're over here on the right. They're both interior. They're inside this section here. And they're touching different lines. This one touches the top parallel line. This one touches the bottom parallel line. The thing we need to remember about same side interior angles is that these are supplementary. And remember, supplementary means that they're going to add up to 180 degrees. Now there is one other pair, but let's write down this pair that we have so far. This would be DCF. So angle DCF. The measurement of that angle plus this angle down here, GFC. Those two are supplementary, so they're going to add up to 180 degrees. But there's one other pair of same side interior angles, and that would be this angle and this angle in green right here. Those two would also be same side interior angles. So we could also say that BCF, the measurement of angle BCF, plus the measurement of angle EFC, that those have to add up to 180 because they're same side interior angles, and same side interior angles are supplementary to add to 180. All right, so we're on to our last thing here. We are going to solve for all these missing angles using the angle pair relationships that we've learned so far. So we've learned supplementary angles, complementary angles, vertical angles, linear pairs, We've just learned corresponding angles. Today we learned alternate interior angles, and we've done same side interior angles. So using all those pieces of information, I should be able to fill out every single angle so far that we've got. I usually start with vertical angles and linear pairs. So let's do that first. I'll do it in red here. So vertical angles, 57 and K, they have to be the same. They're vertical angles, and vertical angles are congruent. So K has to be 57 degrees. Now over here, 81 is not the same as V, because 81, it's not made of two angles here. We've got, or two angles. It's not made of two lines. It's only when two lines cross each other. Look what we have down here. We've got 1, 2, we've got a third line. So we don't really have vertical angles right there. So we've got all of our vertical angles. Let's move on to our next one, which would be the linear pairs. So we've got linear pairs up here. This one and this one together make a straight line. So if this is 157, this and this have to add up to 180 degrees. So what's that going to be, 123? I think it's 123. So using linear pairs, these two add up to 180. And now I can use vertical angles, and M also has to be 123. Now we've got a problem here. This 81, these two together added up with that one should make a straight line. So I can't use linear pairs right here. So I'm going to have to be a little bit more creative in how I do stuff. And the first thing I'm going to do is now I'm going to start working with corresponding angles and alternate interior angles. I could use same side interior angles too, I guess, if I wanted to, but whatever. All right, so I'm going to ignore this little line right here. So I've got a parallel line. This is my transversal. This angle here, 57, and angle R are alternate interior angles. They're on different sides of the transversal. They're both inside these two parallel lines. So alternate interior angles we set up here are congruent. So this angle and this angle are alternate interior angles. So I now know that this angle is 57 degrees. I can also use corresponding angles. Angle H and angle V are corresponding angles. So that should be congruent because corresponding angles are congruent. Linear pairs right here, these two have to be linear pairs. So this one adds up to 57 degrees right there. And now we can see that these two are actually vertical angles. Now 123 is vertical angles with all of this. So S and 81 is 123. So what I could do at this point, well, there's several things. I could add these three together, and these three angles together, R, S, and this one, they should add up to 180 degrees because together they make a straight line. We'll just do that. So we'll say that angle R, which is 57, plus angle S, plus 81, those three together should make a straight line. That's 180 degrees. So let's add up 57 and 81. If I add those two together, I get 138. I'll just subtract 138 from both sides, and I end up with 42. So now I know that S is 42 degrees. All right, I cannot compare going this direction because these two lines are not parallel. I can't use this as a transversal because these are not parallel lines. So I have to compare these angles here with the angles that I have down here. Luckily, I have same side interior angles right here. So I've got parallel line, transversal. F and 81 would be same side interior, and we said same side interior angles are supplementary. So these two should add up to 180 degrees. So we know that F must be 99 degrees. P is vertical angles with that one. So P is 99 degrees. Q and 81, Those are corresponding angles. This one's exterior, this is interior. They're on the same side as the transversal. So this is 81. And then vertical angles, and that's 81. On our next lesson a little bit later, is it the next one? It is the next one. We're going to find out that triangles have to have 180 degrees for their interior angles. And if you add up 57, 81, and 42, yep, you do get 180 degrees. So triangles here, we can see have 180 degrees when you add up the three angles. And that's what's going to be on our next lesson. All right, math hard. See you later. Bye-bye.